All right, everybody, this is the second part of our video, and here we're going to talk about what this particular graph would look like, or this function as an inverse. So this is a rational function. The rational function is going to have a vertical asymptote at x equals 3. It's going to have a horizontal asymptote at 2, which we'll talk more about that idea much later in the course. And when I graph this, let's see, it's going to have an x-intercept at -1/2, so like right here. So the graph is going to kind of do something like this. And then on this side, it'll look like this. And looking at this, we can see that this will pass both the horizontal and vertical line test. So this is 1-to-1. So that means f inverse of x exists. Of course, I know you probably don't know the graph for that, but that's okay. What we're going to do is find its inverse, okay? So knowing that this inverse will exist, we are going to rewrite this as y equals notation. And then what we're going to do is we're going to swap the x and y. Let me write this. I'll write steps out. So we're going to swap the x and y, which allows us to have x equals 2y plus 1 over y minus 3. Okay, easiest way to do this is put this over 1 and cross multiply. So I should write this as a step. If you follow this example for every one of these that you'll see, you should have no trouble with this, okay? And then I'm going to cross multiply x times the quantity y minus 3. Remember, our goal is to solve for the new y. So to solve for y, I have to be able to get rid of those parentheses so I can get the y's not isolated, or not trapped. So this side is just going to stay as 2y plus 1, and this side becomes xy minus 3x. Okay, our goal is to have the y's on the same side, so what I'm going to do is subtract xy from both sides. This gives me the quantity 2 minus x times y plus 1 equals -3x. So we're going to subtract 1 on both sides. And that gives us 2 minus x times y equals -3x minus 1. So now to get that y by itself, we're going to divide both sides by 2 minus x. And we get y, or in this case, what was our variable again? F inverse of x equals -3x minus 1 over 2 minus x. Okay. Don't worry, I do have a plan to do another one of those in class, so if this example didn't make a lot of sense, we'll be practicing this more in class. But I do want to talk about one last thing that could come up, and that is determining if two functions are inverses of each other. Okay, and so what we're going to do is we're going to look at a couple of special composite functions. So that's where we do f of g of x and g of f of x. Now normally when you do a composite function, if you do one versus the other way, you don't always get the same thing. If two functions are inverses of each other, then that means the compositions both ways result in x. So I'm going to model that with two examples here. Okay? So if I do f of g of x on example A, that means I'm going to plug my g of x into the variable for f of x. Okay, looking over here, I'm going to get, let's see, these twos will cancel, so I get x minus 3 plus 3 The minus 3 and the plus 3 cancel, so I just get x. If I reverse and go the other way, and I do g of f of x, that means I'm going to take f and plug it into the variable for g. So that gives me 2x plus 3 minus 3 all over 2. And as you can see, on the top we'll have the plus 3 cancel with minus 3, so that gives us 2x over 2. The 2's will cancel, and we just get x. Since the compositions work both ways, these are examples. Since f of g of x is equal to g of f of x and g of x are inverses. Okay. Now if I look at the next pair, again, let's try f of g of x first. So that means I'm going to plug in g of x to my f of x function. Distribute the 1/2, I get 1x plus 1/2 minus 1. And when I look here, I can see 1/2 minus 1. These don't cancel out. So not inverses. Okay. And even if I tested it the other way around, this is just to be able to verify. If I plug in f of x into the function for g of x, if I look here, that gives me 1x minus 2 plus 1. These again don't cancel, so they're not inverses. Okay, so you could also use compositions to help you verify if two things are inverses or not. Okay. All right. I think just for the benefit of looking at the example that was a lot like this one right here, I'm going to model another situation like this one, okay? Just to find its inverse, okay? So this is just an extra example. So let's let f of x equal 5x minus 3 over 2x plus 1. What is f inverse of x? Alright, so to do this, we know that this is the same as saying y equals that. So I'm going to switch my x and y around. To make life easier, I'm going to put that over 1 and cross multiply. So that gives me 1 times 5y minus 3 equals x times 2y plus 1. Have to distribute, so we get 5y minus 3 equals 2xy plus x. Alright, so now looking at this, let me recopy it here. Gotta get my y's together. Here, the y is in common in both terms, so I'll have 5 minus 2x. And I add 3 to both sides. I get y times 5 minus 2x equals x plus 3. So then I'm just going to divide both sides by 5 minus 2x. And since y is now going to be f inverse of x, I will say that that is x plus 3 over 5 minus 2x. Okay, so just another example there to practice that out. All right, so with that, now you should be able to do the problems that are in Delta Math.